I think it's pretty solid advice.
Groups of cells in different parts of your brain, they're all connected.
The statistics just don't back it up. There's nothing here.
Any complex life you find has mitochondria.
We have discovered things from athletes juicing.
My name is Matt Kaberlein, and welcome to the Optispan podcast.
Hey everyone, welcome to the Optispan podcast. On today's episode, I'm going to talk about the dog aging project, and I will give you an update on where the dog aging project stands today, and also take you through the history of the dog aging project, at least from my perspective. So I'll encourage all of you to check out the dog aging project website to participate in the project. So the project website is dogagingproject.org. And also want to mention that Daniel Promislo, Kate Creevy, and myself have started a 501c3 nonprofit called the Dog Aging Institute. That's dogaginginstitute.org. And we have launched what we call the Kickoff for Canines campaign. So some of you may be familiar with a campaign that we launched earlier this summer through a platform called DonorList or Kernels. We ended up having to move that campaign over to the Dog Aging Institute for circumstances that were beyond my control. There's a little bit of drama there. We won't get into it. Other than to say, we had some prizes associated with that campaign and some people who donated to that campaign. Don't worry, if you're one of those people, your donations will roll over. The prizes are rolling over. So I'll have more information on that Kickoff for Canines campaign coming shortly. But if you want to check it out, go to dogaginginstitute.org, and there's a link there for the Kickoff for Canines campaign. So what I want to do today, though, is talk about the dog aging project sort of overall. And there are really two major goals to the dog aging project. The first goal is to understand the biology of aging in companion dogs. And by companion dogs, I mean pet dogs living with their owners, living in the human environment. So every study in the dog aging project is a study of companion dogs. We don't do any research on captive dogs in the laboratory or in kennels. So the first goal is to understand the biology of aging. And the way that we are doing that is through something called a longitudinal study of aging in companion dogs. So longitudinal just means repeated over time. So if we only got data on each dog at one time point, that would be called cross-sectional. But because we're collecting data on the same dogs over time as they're getting older, it is a longitudinal study of aging. And the goal of the longitudinal study of aging is really to understand what are the most important genetic and environmental factors that influence health outcomes during aging in companion dogs. And of course, lifespan is one of those health outcomes that we're interested in, but it's not the only one, okay? The second goal, so goal number one, understand aging of dogs. The second goal, and this is what I really care about, is do something about it. Actually mitigate the biological aging process in dogs to help them live longer, healthier lives. And the way that we accomplish that is through clinical trials, through testing interventions to understand whether or not those interventions slow the biological aging process in companion dogs and increase lifespan and health span. And at the moment, we have one clinical trial, and I'll tell you more about that clinical trial in just a minute. So that's really the overarching mission vision of the dog aging project. Improve quality and quantity of life for companion dogs, understand the biology of aging, and do something about it. Okay, so why dogs? I think there are a bunch of reasons why, especially companion dogs living with their owners in the human environment, makes a ton of sense for a project like this. One of the reasons is dogs age very much like people do. So while I would say for me personally, the sort of overarching goal is to have an impact on health and lifespan of dogs, without a doubt, most of what we learn is going to be relevant for human aging and can also be used to improve health and lifespan for people. And the reason that's true is because dogs age biologically very, very much like people do, okay? They develop all of the same age-related diseases that we do. They get most of the same age-related functional declines that we do. And those things are age-related in dogs. The only real difference is they happen 7 to 10 times faster in dogs than they do in people, because dogs are aging biologically 7 to 10 times faster than people are. So we can learn a lot about human aging from studying aging in dogs. And because it happens on a time scale that is much compressed compared to humans, we can actually get to mechanistic causal relationships in a time frame that's reasonable, in a period of time of a few years. We can actually test interventions to determine whether or not they slow biological aging in 3 to 5 years, if supported sufficiently with sufficiently powered clinical trials. So it's eminently doable to solve this problem in dogs in a time frame that is reasonable and can potentially have an impact for everybody who's listening to this video right now. So that makes a ton of sense. Dogs also have this really, I think, interesting and powerful genetic and phenotypic diversity. And what I mean by that is, if you think about dogs, everybody's familiar with the idea that there are, a couple hundred breeds of purebred dogs. Those are essentially like inbred strains of mice, right? They're very genetically homogeneous, very genetically similar to each other. But on top of each of these purebred breeds, we've got this really interesting mixed breed background, the mutts of the world. And that genetic architecture is quite powerful, especially when we combine it with the fact that phenotypically, when we think about traits, visible traits, dogs are quite diverse, right? Just think about body size and the difference in body size between a Great Dane and a Chihuahua, right? It's much greater variation than we see in body size in people. So that combination of genetic architecture combined with phenotypic diversity is very powerful for mapping genetic variants onto traits. So that's something that is kind of unique about dogs in the animal kingdom. And then I think a really big one is that dogs share, to a large extent, the human environment. Diet, of course, is a little bit different, but outside of diet, our companion dogs really share pretty much every aspect of our environment. So just like in people, there are rich dogs, there are poor dogs, there are dogs that have a healthy lifestyle and dogs that have an unhealthy lifestyle. Those things are all parts of our environment that we can actually study and their impact on the biological aging process. You can also think about things like water quality and air quality. So most people don't give their dogs bottled water. Dogs are getting tap water most of the time. Dogs are breathing the air that we're breathing. We know a lot about air quality and water quality that these dogs are experiencing because we know their zip codes and the government tracks air quality and water quality. So in many ways, dogs can serve as a canary in the coal mine to some extent for how these different environmental factors are influencing the biological aging process, as well as specific health outcomes, specific diseases of aging, or even other types of diseases that can be uncovered in a much quicker time frame in dogs than is possible in people. And then, I think this little bit more nebulous, but maybe even the most important factor about the Dog Aging Project and why dogs is people love their dogs, right? I think, I've always been a dog person. I've always had dogs in my lives. I've loved my dogs. I have one geriatric German Shepherd now. His name is Dobby, and I love him dearly. I think like many people, I consider my companion animals to be part of my family. And so a study of aging in dogs is a study of aging in people's family members. And if we're successful at slowing the aging process, increasing lifespan, improving health span in dogs, that will have a big impact on the way that the general public views the study of aging, the field of longevity. So impacting quality and quantity of life for the dogs has an impact on quality and quantity of life for their human companions. So I think for all of those reasons, dogs are a quite powerful and valuable animal in which to carry out this kind of a study. So the structure of the dog aging project, you can sort of think of it as nested groups or nested cohorts. The largest group within the dog aging project is what we call the dog aging project pack. So in order to become a member of the pack is open to all dogs. So purebred, mixed breed, young, old, puppies. We want all dogs in the dog aging project pack. We want to capture the diversity of dogs that are out there. So the largest group is the Dog Aging Project Pack. To become a member of the pack, all you have to do is go to the Dog Aging Project website, dogagingproject.org, click on the Nominate My Dog menu item. When you do that, you will be asked for just some basic information, your name, email address, zip code, things like that. Then you will be invited to create your own owner portal within the Dog Aging Project infrastructure. Once you've done that, you will be invited to complete what we call the Health and Life Experiences Survey, or HLES. That's the acronym we use within the Dog Aging Project. This is an extensive survey. It is our primary data capture tool that attempts to get information about as much of the dog's environment and health history as we possibly can. So it's pretty extensive. It'll take anywhere from an hour to 2 hours to complete. There are 10 modules. Doesn't have to be done in one sitting. But everybody who successfully completes HLES becomes a member of the pack, and you will get your Dog Aging Project pack number and certificate. Once you've become a member of the pack, you will then be asked to provide what's called a qualifying electronic medical record, or veterinary electronic medical record, VEMR. This can be done by asking your veterinarian to send the record to the Dog Aging Project, or get the record itself and then you upload it into your owner portal. People who are successful at providing a qualifying VEMR then become eligible for the other groups within the Dog Aging Project. We call these the sampled cohorts, because these dogs then are eligible for additional study through the collection of biological samples. So the largest sampled cohort we call Foundation. This is the genetics or genomics cohort. So every dog in the Foundation cohort has its genome fully sequenced. And this is really easy. It's a cheek swab. You swab the inside of the dog's mouth, send the kit back, and the genome will be sequenced. Again, for owners whose dogs are in the Foundation cohort, you will get a genetic report on your dog. You should be careful because you might find something you didn't expect. It is not uncommon that people who believe their dog is 100% German Shepherd will find out their dog is only 95 or 90 or 80% German Shepherd. I can tell you from experience, you may be surprised. So just be prepared for that possibility. So the goal is to sequence the genomes of 10,000 dogs, and we're very close. More than 9,000 dogs have had their genomes completely sequenced within the Dog Aging Project. We would love to sequence the genomes for all the dogs in the Dog Aging Project pack. Resources available, easy to do. Okay, so then the other cohorts are focused on different aspects of biology. So one of the cohorts is what we call a centenarian cohort. So centenarian means living to be more than 100 years old. These dogs don't actually live to be more than 100 years old. But the idea here is that there are dogs who live much longer than we would expect them to live based on their body size. So body size is the most important determinant of lifespan in dogs. Big dogs live shorter and appear to age faster in most ways than small dogs do. So if a dog lives exceptionally long for its body size, it becomes eligible for this centenarian cohort. And the idea here is that there may be genetic or environmental variants that are strongly associated with exceptional longevity in dogs, and maybe we can find them. So those dogs get their genomes fully sequenced at high coverage. There's what we think of as the systems biology cohort. So this is where we do what's called multi-omic analysis. 1,000 dogs in the precision group have a sample collection kit sent to the owners. The owner brings the kit to the veterinarian at the next checkup to collect blood, urine, feces, and hair for different types of analysis. And this includes metabolome, epigenome, microbiome, so that's the multi-omics, on each of the dogs. And this is done annually to see to what extent can we identify new molecular signatures that predict health, that predict longevity, and potentially lead to hypothesis-generating ideas for those connections that can then get towards mechanisms. So that's the precision group. We have a dedicated study of cognitive function and brain health. This is the brain health study. This is based on the fact that, just like in people, many dogs, as they get older, will show cognitive decline, and a subset of those dogs will develop dementia, something called canine cognitive dysfunction. So we have a survey tool that assesses cognitive function for every dog in the pack annually. And then a subset of dogs are selected for the brain health study, where it's very much like the precision study, where we're collecting multi-omic, high-dimensional data sets on those dogs annually to assess, again, can we identify features that are strongly correlated with cognitive function and risk of dementia in dogs. So that's the brain health study. And then there's the clinical trial, TRIAD, test of rapamycin in aging dogs. TRIAD is the only part of the dog aging project that goes beyond being observational. So in the rest of the dog aging project, we're not asking the owners to really change anything that they do in the way they care for their dog. In TRIAD, it's a double-blind, randomized, placebo-controlled veterinary clinical trial with the goal of testing, does rapamycin increase lifespan and improve health span metrics in dogs? So this is an ongoing clinical trial, and here the owners are asked to provide their dog with the study medication or placebo, they don't know, regularly throughout the period of the clinical trial. And I'll do additional episodes that do a deeper dive into the longitudinal study and into the clinical trial for those of you who are really interested in, diving into how this is done. But that gives you a feel for the overall structure of the dog aging project. So as of today, there are more than 50,000 dogs in the pack. So 50,000 dogs around the United States participating in this long-term longitudinal study of aging in companion dogs. HLES has up to almost 5,000 questions. Nobody really answers 5,000 questions because there's, sort of branching logic tree to the survey, depending on what your prior answers are, but it's a lot of information. As I mentioned, we also have veterinary electronic medical records. I think it's for about half the dogs in the pack. And then annually, we collect this cognitive assessment. We call it Canine Social and Learned Behavior Survey, CSLB. It's a measure of cognitive function in dogs. So we have that data for all of the dogs in the pack, and for many of them, we collect updates annually, again, as part of the longitudinal study. So this is a very, very large, in-depth data set. And I think the only thing I want to leave you with today is we are just scratching the tip of the iceberg in terms of what the dog aging project team can actually analyze. There's a lot of super interesting questions that can and should be asked. And again, we're just at the tip of the iceberg. So this is a very, very valuable data set that is being collected. And for that reason, one of our core values is that we are an open science project, meaning we make the data collected available to the scientific and academic community for free on an annual basis. So we published a paper in Nature in 2022. The title of that paper is An Open Science Study of Aging in Companion Dogs. And it goes through the types of data that are being collected, the types of biological samples that are being collected. So we have a biobank at Cornell University. So we have biological samples and annual data that is made available, again, on an annual basis to the scientific community. If you are at a university, at a nonprofit institute, and you would like to dive into this data, I encourage you to go to the website, request data access. There's a very simple data use agreement. Complete the data use agreement and go to it, because there are just a bunch of super interesting questions that can be asked and a lot of really cool science just waiting to be done. So check it out. I hope some people will take advantage of this and do the kinds of things that we just don't have the bandwidth to do on the Dog Aging Project team. Okay. So that gives you an overview of the Dog Aging Project. What I want to do now is kind of take you through a brief history of the Dog Aging Project. Again, this is from my perspective. Obviously, we all see things through our own lens. And if Daniel or Katie were to do this, they probably would give a slightly different history. But this is Matt's version of the Dog Aging Project from the very beginning. So for me, I would say the Dog Aging Project really started around 2014. So Daniel Promislo, Kate Creevy had been thinking about dogs as a model for aging well in advance of this. So they had started something called the Canine Longevity Consortium, or CLC, through a small grant from the National Institute on Aging. It's what's called a planning grant, which is a grant that allows people to hold a series of small meetings to kind of talk through a new idea. And so they had a series of conferences, again, very small conferences, bringing in veterinarians and epidemiologists and statisticians and geroscientists to kind of talk about the idea of, what could be done in the realm of dogs as a model for aging biology, with the eye towards a longitudinal study of aging, which is what the Dog Aging Project evolved into. And that happened, I don't remember when Daniel first got the grant, but this was probably about 2011 through 2013, something like that. And I went to one of these CLC meetings, fascinated by the idea. And then Daniel relocated to the University of Washington, and he and I became course directors for the Biology of Aging summer course, which was held every year at that time at Woods Hole, Massachusetts. This was a summer course funded by the Ellison Medical Foundation. And just as a very quick tangent, I had something come across my radar the other day, kind of banging on Larry Ellison, that he hadn't supported geroscience research enough, and he spent all his money on yachts and things like that. And I saw that, and I'm like, these bozos don't know anything about the history of geroscience. If in my view, if you really think about like the high net worth, and again, I'm not trying to defend Larry Ellison in any way. I don't know Larry Ellison, but if you think about the high net worth people who have had an impact on the field, I don't think there's anybody who's had a bigger impact on the field of geroscience than Larry Ellison. He founded the frickin' Ellison Medical Foundation, which supported most of the leading scientists in the field at some point in their career. And also supported this summer course on the biology of aging at Woods Hole every summer that Daniel and I directed. So that's the tangent. But I do appreciate you, Larry, even though you pulled the plug on the Ellison Medical Foundation right before I was supposed to get my senior scholar grant. So that part I didn't appreciate. But by and large, Larry Ellison has had a huge impact on the field. And again, I think most of the leaders in the field today were supported by the Ellison Medical Foundation, often at a very critical time in their career. So I think the Ellison Medical Foundation is not appreciated for how much of an impact it had on the expansion of the longevity field over the last 20 years or so. Okay, all of that being said, it was really that summer course at Woods Hole it was 2014, one of the 2 years that Daniel and I co-directed it, that led to the Dog Aging Project as it is today. So, as I mentioned, I went to one of the CLC conferences, and Daniel and I at that summer course spent, a fair amount of time talking about this idea of dogs as a model to study aging. And as I mentioned earlier, I've always been a dog person. I consider my dogs part of my family, and it immediately resonated with me why dogs provided a lot of advantages for a longitudinal study of aging. But the light bulb moment was when I realized at this summer course that we've been studying these things in laboratory mice, like rapamycin. My lab was working on rapamycin at the time, caloric restriction, that increased lifespan, 20, 30, in the case of caloric restriction, 50, 60%, seem to prevent, at least delay, most of the functional declines and diseases that go along with aging. These things work in fruit flies, they work in nematodes, they even work in individual single-celled yeast, almost certainly going to work in dogs. And that recognition, which is obvious in hindsight, it's like, why didn't I think of this earlier, was the moment when I was like, oh my God, we can actually increase lifespan in people's pets by, I don't know, a year, 2 years, 3 years, 4 years, 5 years. I don't know, but it's doable. Like some of these things that slow aging in mice will slow aging in dogs. To the extent that I can be certain about anything as a scientist, I'm certain of that. Like the probability is above 99% that we can slow biological aging in dogs and significantly increase health span and lifespan in our companion animals. That was what went on in my head. And then it was like, well, I got to do it. Like there's no question about it. That is the right thing to do. I got to do it. So that was the moment for me when it was like, okay, this went from a cool idea to something that has to happen. And then it was just a matter of going out there and figuring out how to get it done. So for me, that's when the dog aging project started. And so I started talking to lots of people. I think most people thought it was they got it. They were like, yeah, that makes sense, but you're never going to be able to do it. Like you can't do a clinical trial on people's pets. Owners won't do it. NIH won't fund it. So there was a lot of that, typical, I think, academic conservatism. Like that's too good of an idea. That's too high impact. You're not going to be able to do it. And fortunately, I'm not the type of person to let that get me down. So I pounded the pavement, started trying to raise money here and there. And as these things sometimes happen, I was being interviewed by a journalist for Nature about a completely different story. I honestly don't even remember what the study was that she wanted to get my opinion on. And somehow this topic of dogs came up, probably because I couldn't stop thinking about it, talking about it. And she immediately was like, oh my gosh, that's amazing. I'm going to write about that. So she wrote a 600, 700 word article in Nature about testing rapamycin in companion dogs. And right around that same time, I had gotten a small amount of money for a conference that we actually held in Seattle around planning for how we can study aging in companion animals and carry out potentially clinical trials in companion animals. And it was at this conference when the Nature article came out. And then almost immediately that got picked up by The Guardian, which is a UK media outlet. And they put out a story which kind of then, started the snowball. And within a week, the Seattle Times, which was our local newspaper, was wanting to interview Daniel and myself about this clinical trial we were doing in dogs of rapamycin, which we didn't even really have the money for at that point. And so that was when I was like, oh crap, we better put a website up so we can actually start to capture information for owners who might want to participate in this clinical trial that we don't actually have funded yet. But we were close at that point. I had lined up most of the resources to be able to do this first phase clinical trial. And I do also want to say at this point, thank you to Felipe Sierra, who at the time was the director of the Division of Aging Biology at NIA, who allowed us to use some carryover funds from our Nathan Schock Center at the University of Washington to get me the last, it was like $60,000, $70,000 of the way across the finish line for this clinical trial. So anyways, Seattle Times wanted to interview us. I was like, oh crap, better build a website. So my wife and I, mostly my wife, built a website over the weekend before the Seattle Times article came out. And we were like, what do we call this thing? We're like, well, it's aging and it's dogs. Let's call it the Dog Aging Project. And that's how the Dog Aging Project was born. So we put the website together. We had a form where people could register their interest in participating in this clinical trial. The Seattle Times article came out, and within a week we had, I don't remember, a few hundred people who had said, yep, I want to participate in this clinical trial. So we started what we call RAPA Phase 1 at a VCA veterinary specialty clinic in Linwood, Washington, which is near the University of Washington. The goal of that trial was safety, first and foremost. Proof of principle that you could actually do this kind of a clinical trial in dogs. But we knew from studies in mice that short-term treatment in aged mice with rapamycin could reverse degenerative changes in heart function, and that this could be seen by echocardiogram. So we included echocardiograms as part of this rapamycin phase 1 trial. So the design of the trial was the dogs come in, they have to be relatively healthy for their age, so they can't have pre-existing disease, And at that point, we decided they needed to be middle-aged. So I think we started at 6 years old. Then they had to be relatively large, so at least 40 pounds. So they had to be relatively healthy, middle-aged, relatively large to be in the trial. And they would get an echocardiogram at that first exam, then be randomized if nothing came out that was a pre-existing condition from that first exam. And there were 3 groups: placebo group, low dose, which was 0.05 milligrams of rapamycin given Monday, Wednesday, Friday, 3 times a week, or high dose, which was 0.1 milligrams of rapamycin given Monday, Wednesday, Friday. And the reason we picked those doses was mostly, again, around safety. We were fortunate that something called the Canine Oncology Trials Consortium had already been carrying out studies of osteosarcoma in dogs with rapamycin, and they had established that this 0.1 milligrams per kilogram 3 times a week dose was safe, right, in terms of no significant adverse events. So again, the safety piece, I think, people who've never really thought about doing a clinical trial in companion dogs may not immediately get, but this is very much like a pediatric clinical trial. People consider their dogs in many ways the same as they consider their kids. The last thing any of us wanted to do was hurt somebody's dog. So when you're designing a clinical trial like this, you really have to be super cognizant of safety and do your due diligence to make sure that the intervention is going to be relatively safe, at least safe enough to offset or where the reward outweighs the potential risk. So that's why so much emphasis on safety. Okay, so anyways, we got this trial going, had echocardiogram. So after the 10 weeks, this was a 10-week period of treatment, and then they get an echocardiogram at the end of the 10 weeks. And we had blood work at the beginning, middle, and end. That was really the design of the phase 1 trial. So we did that study. Fortunately, no significant side effects were detected, so that's good. A couple of interesting things came out of the owner surveys. One was the owners self-reported improved activity in the dogs that were getting rapamycin. Again, recall the owners didn't know if their dog was getting placebo or rapamycin at the time they were completing these surveys. We didn't specifically ask about activity either. That was a self-reported thing. The other thing which is funny, I still don't know if it's real, but it's intriguing, is again, we didn't ask. The owners self-reported, 25% of the owners whose dogs got rapamycin self-reported that their dogs were more affectionate. So I don't know what that means. I think it's cute. I think it's cool. Maybe it reflects an underlying change in cognitive function, but I really don't know. So increases in activity, improvements in affection, no significant side effects. But also for 2 of the 3 echocardiographic endpoints that we were looking at, there was a statistically significant improvement in the dogs that were getting rapamycin. So very small study, underpowered. We intentionally did not overinterpret that data, but intriguing, and I think arrow pointing in the right direction, supporting the importance of future studies, suggestive of positive benefits from rapamycin as well. So that got picked up by the New York Times. Amy Harmon wrote a great article in the New York Times. This was pretty cool for me. So it turns out that I was actually in New York for an American Federation for Aging Research event at the time that this article came out. And my wife and I were just walking down the street past a newsstand. This was actually like print newspaper, and we saw Dog Aging Project on the front of the New York Times. That was really pretty frickin' cool experience. So that happened in 2016. That directly, I think, facilitated a grant from a family foundation, the William H. Donner Foundation. Again, I have a huge amount of gratitude to the Donner Foundation for letting us then get the Dog Aging Project to the next level. That supported our phase 2 rapamycin clinical trial. So this was designed as a 6-month clinical trial, and that was carried out at Texas A&M University. We intended to enroll 50 dogs into that trial. We actually stopped the enrollment early because in 2018, we got our first National Institute of Health, National Institute of Aging grant to support the Dog Aging Project. And this was really the heavy lift of Daniel Promislow and Katie to get what's called a U19 grant. So this is a large grant mechanism that the NIH has to support both the longitudinal study of aging and the large rapamycin clinical trial, which we've called Triad, Test of Rapamycin in Aging Dogs. So this original U19, funded in 2018, was to support both the longitudinal study of aging and Triad. And for those of you who aren't in the weeds on NIH grant mechanisms, the vast majority are 5-year grants, and then you have to reapply for continued funding. The expectation typically is if you meet your milestones, you're showing progress, and your grant has an impact, high impact on the field, that continued funding will happen as long as you meet those milestones and continue to have impact. So I think we were all optimistic that this was the beginning of a very important high impact project in the field. So that was 2018. Again, for bureaucratic nonsense reasons, the grant was funded, I think, in June. None of the money actually came in until, December or something like that of 2018. And that's when we could really start to get to work. And so the first thing we had to do was to create the core infrastructure for the dog aging project. So if you really think about what it takes to carry out a large-scale longitudinal study of aging and a large clinical trial distributed across multiple veterinary teaching hospitals, you need a lot of freaking infrastructure for a project like that. Where are the owners going to go? How do they sign up? How do we collect data from the owners? How do we get the medical records? How do we engage with veterinarians? How do we ensure that the clinical trial is done to the highest quality standards? Where are we getting the drugs from? Like, all of this stuff had to be solved in order to build the dog aging project. So that's to say that a lot of effort had to go into building the infrastructure that exists now. If you go to the website, you'll see and sign your dog up. If you've done that, you know that the infrastructure is pretty solid, but all of that had to be built. So that's really what the project focused on and the team focused on from like end of 2018 to end of 2019. It took about a year to build that infrastructure. And so the goal at this time was to enroll 10,000 dogs into the Dog Aging Project PAC and 280 dogs into the randomized clinical trial, into Triad. Okay, that was what was in the 2018 grant. And I'll come back to this. Okay, so first year spent building the infrastructure. In late 2019, and I know it was late 2019 because we did this at the Gerontological Society of America meeting in 2019, and that is always held in November. So in 2019, November, we made the launch of the Dog Aging Project PAC. And so we had a symposium at GSA. We had multiple media outlets publish stories about the launch of the Dog Aging Project PAC. And within a few months, we had 24,000 dogs in the PAC by like mid-2020. So already exceeded the milestones for the entire 5-year grant, at least in terms of number of dogs enrolled in the trial. Then in 2020, the Dog Aging Project Biobank was funded. So we actually created this biobank at Cornell, which was actually not part of the original grant. Okay, you guys know what else happened in 2020? That's right, COVID-19. So that created a challenge for the clinical trial. It's very difficult to enroll dogs into a veterinary clinical trial at veterinary teaching hospitals when all of the hospitals are closed for about a year to anything except for emergency services. Y'all remember what that was like? You couldn't go visit anybody in the hospital. If you had to bring your dog to the veterinarian, you had to like meet them outside with a mask on and they would bring your dog inside. Yeah, that doesn't work for a clinical trial. So we could not enroll dogs into the clinical trial in the middle of the COVID-19 pandemic. I get it. It sucks, but there really wasn't a lot that we could do about it. Okay. So instead, we focused on what we could do. We also had a lot of challenges with supply chain. You guys remember that? You remember going to the grocery store and you couldn't find any toilet paper? Think about what it was like trying to get tubes to collect blood or DNA from dogs. So there were supply chain challenges too. So we did what we could and really focused on strengthening the infrastructure and enrolling more dogs into the longitudinal study, which got us up to about 45,000 dogs by 2023. So again, way exceeded the milestones for the project. So we did the best we could given the situation that was happening in the world in 2020, 2021. We did manage in 2021 to put the first curated data release out and available to the scientific community. So that is the open access database hosted at the Broad Institute, so that people can dive into the data we're collecting and do cool science. We published the Nature paper in 2022. We actually expanded the clinical trial in 2022 as things were coming back online and we could actually start to enroll dogs. We were very fortunate. And again, I said before, I have a lot of gratitude to the Donner Foundation. Got a lot of gratitude to a lot of people. In 2022, we had a set of very generous donors step up and donate $2 million to the project to expand the size of our clinical trial. Now, why did that happen? That happened because I was talking with Peter Attia. I was actually doing his podcast. I've been on his podcast a few times now, and we were talking about rapamycin, and of course the clinical trial came up. And he asked, I think, the very insightful question of, how big is the trial, and why are you studying 280 dogs? And I told him the honest answer is that's the number of dogs we're enrolling because that's how much money we have in the grant from NIH. He's like, well, how many dogs would you want to have if money wasn't an object? And I said, well, I think we're pretty good. I think we're right in the range where statistically, we should have power to detect about a 20% change in lifespan or 15% change in lifespan. I think it was at the time. And, he said, well, but wasn't the first study of rapamycin, wasn't that a 9% change in lifespan? I'm like, yeah. He said, well, why aren't you powered to detect a 9% change in lifespan? I said, because we don't have enough money to have that many dogs. He's like, how many dogs would it take? And I had to say, well, I don't know, but I can find out for you. And he's like, go find out. So I did. And it turns out we need 580 dogs to have a 90% power to detect a 9% change in lifespan, given the demographics of the dogs that we're working with. And so I got back to him and I said, we're going to need about 580 dogs. It would require about an additional $2 million to be able to enroll that, additional 300 or so dogs. And Peter very rapidly went out and lined up a collection of generous donors to support the project. So that's how we got to the triad expansion in 2022. Okay, so again, that's 2022. We're cranking. And I mentioned the grant was funded in 2018, 5-year grant. So typically you'll start working on the grant renewal proposal, about a year before the grant runs out. And so we did that. We put together all of the things that we had achieved. At that point, 45,000 plus PAC members, more than 9,000 genomes sequenced. Triad at that point had enrolled about 100 dogs, a little bit more than 100 dogs, I believe. Again, given the constraints of the pandemic, we felt that was pretty good progress. We created this open access database with annual updates, collected at that time more than 1.6 million data points, created this open access biobank at Cornell. We'd gotten this brain health study funded through another NIH grant that I was able to obtain to create a dedicated dementia study within the dog aging project. And we submitted the grant, very confident that the grant would get renewed because we had, in most cases, exceeded the milestones. And in the cases where we hadn't exceeded the milestones, felt like, given the situation of the pandemic, there were reasonable explanations for why we hadn't exceeded the milestones. And as many of you probably know, the grant was not renewed. And I'm not going to get into the details of the NIH review process. Some of you know the inner workings. I'll just say, I would characterize the most likely reason why the grant wasn't renewed as just bureaucratic incompetence. I don't know. I don't think there was anything corrupt about the process. I just think it was just one of the most boneheaded decisions that I have ever seen. And I know many of you will be like, well, the government makes boneheaded decisions all the time. Yeah, that's true. This, in my view, there's just no explanation, but that's what happened. So, in 2023, we received word that the grant was not going to be renewed. If you compare the aims of the grant to the actual, we built the infrastructure, we were supposed to enroll 10,000 dogs. At that point, we had over 40,000. We were supposed to sequence the genomes of 10,000 dogs. We had about 9,000. We were supposed to get 1,000 dogs in the systems biology cohort, precision cohort. We had almost 1,000. We built the infrastructure for the clinical trial. We launched it. We were enrolling dogs. We didn't hit 280. We had more than 100. We'd created the open access database, and then we did a bunch of stuff that wasn't even in the grant, like building a biobank and creating a dedicated brain health study, published 45 papers, generated enormous public support for geroscience. I think this, to me, is where I just really don't get what the hell the reviewers and the folks at NIA were thinking. This project engaged 50,000 Americans in geroscience research. Has there ever been anything that has had such a positive impact on goodwill for the field ever? It's hard to imagine. And yet the grant was not renewed. So that all happened in the middle of a global pandemic. Okay, enough said. So that led to what I would consider a very uncertain future for DAP going into the end of 2023, early part of 2024. So NIA Council was not allowed to consider the grant for funding, even though they could have funded it. As many of you know, I submitted a petition to the NIH director, the new director of NIH at the time, with more than 13,000 signatures to support the project, or at least help us figure out a solution. The NIH director was too busy to talk to me. And in fact, I got a nice email from the University of Washington telling me that I could not talk to the NIH director about this. Think about that. The NIA staff is great. So they really, I think, wanted to support the project. They encouraged new submissions of grants, which Daniel and Katie did. That is the right thing to do. Unfortunately, it's about an 18-month timeline. And going into 2024, the project was going to be dead in the middle of 2024 if we didn't get additional funding. So new grants, still hopeful, will be fantastic. Not going to solve the immediate problem. So Katie put in a grant for the rapamycin clinical trial to finish that up. The suggestion was to take the trial out of the U19 and put a separate grant in. Daniel has put in a resubmission of the U19 along with Katie and the rest of the team. As many of you know, I'm no longer in academia, so I'm not formally involved in those grants. So that's where we were about 7-8 months ago. And it was a tough time, I'll be honest with you. And as you can tell, I'm still kind of pissed off about the whole thing. But fortunately, we're at a better place now. So Daniel, Katie, and I created the Dog Aging Institute, as I mentioned. At the time, we knew we needed $1 million to keep the lights on, to keep the core team and infrastructure supported. Because if, you create something like this and then everybody has to go find a different job, rebuilding that from scratch, almost impossible. So we knew we needed that sort of minimum to really keep the lights on until additional resources could be obtained. I think long-term, my hope would be that the Dog Aging Institute, or maybe even a for-profit initiative, and I have no intention of creating that. I'm just saying maybe that's a path. I would love to see the Dog Aging Project be independent of the vagaries of NIH funding and the way that system works. For now, the project is still dependent on that. But I would like to see us be able to raise sufficient funds to become independent of the NIH. So we knew we needed $1 million. And the good news is we've been successful through philanthropic sources in raising that much money. So in particular, again, enormous gratitude to the Tiny Foundation and the Glenn Foundation that put up matching $500,000 grants, one directly to the Dog Aging Institute, one to Daniel Promislow, and then Ken Coit, who also put in a $100,000 donation to the Dog Aging Institute. So we are now well over 1.1 million. That's enough to keep the project going. Fortunately, the R01 that Katie submitted for Triad got a really good score. I think we're all very optimistic that that grant will be funded. That's great news. That will allow us to complete the rapamycin clinical trial. Still awaiting review of the U19. I've gone from cautious to cautiously optimistic. So hopefully that grant will have a better outcome than it did last time around. And the Dog Aging Project will be back in business, off to the races for the next 5 years. But again, my hope will be that in that time frame, the project can become independent of NIH and functioning on its own. I think there's still a ton of really exciting, really important stuff to be done. And just to give you an example, I think, rapamycin's great. I talk about rapamycin a lot. It's our best shot on goal. But the reason you do clinical trials is because you have to actually show that something works, and there's no guarantees. And we've got lots of other shots on goal. I think, a collection of experts in the field could probably come up with somewhere between 6 and 12 interventions that could be tested safely in companion animals that have a pretty good shot at least improving aspects of health span and potentially significantly increasing lifespan. There's really no good reason why those aren't being tested right now, except nobody stepped up and put the resources or infrastructure in place to do it. We should, as a field, we should do that. Like this, again, to me, this is a no-brainer. Like, seriously, why haven't we done that yet? And it's just a lack of commitment and a lack of, I think, support for really important, high-impact, innovative projects. So again, whether that's done through the Dog Aging Project or through some other mechanism, I think it should be done because I still believe firmly that we can and will slow aging in companion dogs, and that will have an outsized impact on the field, directly impacting quality of life for the dogs and the owners, and convincing people that this is feasible, possible, doable in humans, right? If they see it in their family members, their companion animals, that's going to resonate in a way that, seeing an article about how somebody did this in mice doesn't. So again, I don't know why I do know why it hasn't happened yet, but it's a source of frustration and it should happen. Okay, there's lots to do. That's the take-home message. Again, the project's been super productive, more than 50 papers now, more than 2,600 citations, H-index of 24. That's higher than the H-index for a lot of tenured professors in biomedical research. Pretty good for a single project that only has had one NIH grant. Open access data repository and biobank. More than 90,000 people subscribed to the Dog Aging Project newsletter, more than 50,000 Americans engaged in geroscience research, broad positive media coverage for the field at a time when still a lot of the media coverage for science isn't that great. It's nice to have something that makes people smile, makes them feel good about science. And I've been particularly pleased to see that we're just starting, and again, really early, but starting to see some biotech companies follow the template that we've built with Triad to think about moving interventions forward through an FDA approval process for clinical trials targeting aging in companion dogs. And I hope that we will see more of those kinds of clinical trials. So the team is fantastic. It is a highly interdisciplinary group of really, really outstanding people in the Dog Aging Project. This is an image from our 2023 annual meeting. One of the prizes, actually, I'll just mention as part of the campaign at the Dog Aging Institute, is an invitation to come to the 2025 annual meeting to have lunch with myself, Daniel, and Katie. If you don't want me there, I don't have to be there. You can just have lunch with Daniel and Katie if you win the prize. But you can come meet the team and, top people from a bunch of top research institutions around the United States and even internationally. And that's one of my goals for the future as well, is I would love to see the Dog Aging Project become an international project. And I've got some irons in the fire, so to speak, to see if we can actually make that a reality. So I'm enthusiastic about making this a worldwide project going into the next 5 years. Okay, so thank you all for taking the time to watch this video. Again, we'll have more on the Dog Aging Project, the longitudinal study, the clinical trial, get deeper into the details. If you are so inclined, I would encourage you to participate in the Kickoff for Canines campaign at the dogaginginstitute.org. You can even create your own team. We're going to have lots of prizes, some cool prizes that I'll go through in a short video coming up in the next couple of weeks. And if you want to support the project, I'd encourage you to support the project through the Dog Aging Institute. Thanks so much for watching. As always, any questions or comments, please leave them below. If you're not yet a subscriber, click the subscribe button, and I hope to see you next time on the Optispan podcast.